In this video, we're going to introduce our first scheduling algorithm. So this is called as first come, first serve. Essentially what it is it's based on using a queue. So first in, first out data structure. So this is going to be basically our rule, right? So every algorithm we're going to look at has some sort of a rule that lets us determine what is the next process I should pull out, right, and allow to run, right? This one's basically following that first come, first serve rule. So the first question for you guys here, right, is this a live algorithm? The answer to that is yes, I could treat it as a live algorithm. Because all I have, right, is I have more processes running. They kind of all queue up behind the first thing. That's kind of going to be fair game for me here, right? I don't, my mechanism here, right, doesn't need me to know, about all the processes that are out there. All I need to know is about the order they have arrived in. So this is indeed something I could use as a live algorithm. That said, it won't be very efficient. So the first thing we want to talk about is actually our sense of, our model here, right? So we're going to try and kind of demo this thing. But first we need some sort of representation of processes. And so that's what I have over here. So I have basically these tuples here that have a process and then its burst time. The first element of every tuple is going to be basically a process ID. So this is P0, right? P1, P2. These are all kind of different processes that are running. And if I had, different bursts from the same, process, I might have, another, P2, comma 4, something like that at the end or something like that. But anyways, first thing, right, is basically what process is this burst coming from. Second thing is, how long is the burst, right? So these are burst times. This is 10, 5, 8, right? So these are my tuples. So these are basically my jobs that I have available, what process they belong to, or I should say these are my bursts, right? These are the things I need to schedule. So it's what process and then how long is that burst. Now for here, what I'm going to effectively assume is that they arrive in order, right? So this is kind of my first one, right? And then this is kind of my last one over here. So that's the order that they arrive in. And so usually what I do, right, is I start by saying, okay, this is my model, right? These are the jobs I want to schedule. And then I'll draw it. So I have basically this diagram here, and you can see that I have basically my P0, P1, P2, right? Those are kind of side by side. This is kind of a very typical drawing, right? I have these processes running. And on the bottom, you can see that I've annotated what are the current times. So here, right here, right, this is time 0, right? Nothing has happened yet. P0 is going to be there, right? Kind of is the first thing in line. And obviously, right, because they're first come, first serve, I need to go P0, P1, P2, right? That's kind of my ordering here. And so P0 is first. Then I have my P1, right? And P1 starts at time 10, right? Because P0 lasts at 10. And it ends at time 15, right? Because it ends at basically its duration, right? 5 plus the starting time, which is 10. So I have 15 there, right? So that's my end time on P1. P2 starts up immediately, right? There's no gap or anything like that. And if I want to calculate when it ends, right? It ends at 23 because it ends at 8 plus the 15, right? It's its duration, right? Plus the previous thing. And so I have there my diagram, right? My diagram shows, the process is in order, right? And I figure that out by the rule, and then I annotate the times on the bottom. So this is what I'll kind of draw if I'm trying to get a sense of how things are running. Now what we want to do, right, is basically measure things according to the criteria that we introduced earlier. And so I have kind of these 5 things here, and let's kind of go over them one by one. First of all, I have CPU utilization. Here it's really not important. Somehow, right, our utilization is probably going to be 100%, right? Because notice that I have processes running, right? So I'm going to have something on there. Right? That should be fine. Throughput also isn't really a fair question to ask here because I don't really know what my duration is, right? If my duration is, or my throughput, period, if that's 1 millisecond, then my throughput is 0, right? If it's 50, then it's 3. So that kind of, I need to have a good idea of how to pick my interval. Otherwise, I can't, or my period. Otherwise, it's not really fair for me to measure throughput. For now, I'll just write the number 3 here, right? So this is kind of total throughput. It completed everything. Okay, so completion time. So these are going to be kind of the 2 things that we do want to compute is completion time and the waiting time, right? These are the ones that you should be able to do numbers for. So completion time is basically we're going to add up, the ending time of each of these, right? So I have my 10 for my process 0, right? My 15 for my process 1, right? So I have those 2, and then my 23 from the last one, right? So I'm adding basically the completion time of all of them. Here I'm taking the average, so I'll divide by 3. So you can see the same math as over there. But again, right, you can kind of see there's some sort of mapping between this thing going over here and then like this, and then do my division by 3. Okay, so my waiting time, right? My waiting time is somehow just like shifted a little bit, right? So if you notice, right, I took these kind of last 3 numbers I've written here. My waiting time is basically the first 3, right, shifted to the left by once. So here, right, the first process waits 0, first process waits 10. Second process waits 15, right? So I have there my 0 plus 10 plus 15, right? And then all divide by 3 because I'm taking the average of all that stuff. So again, right, it's like I'm taking this starting point here, right? I want to know when things started, right? The first one weighs 0, so I start with a 0, right? Then the next one weighs 10, then 15, and so on and so forth. Everything else, take the average. So I have here my 16 and my 8.3, right? So that's my average completion time and average waiting time. Last thing there is response time. Response time would be hard for us to measure simply because we don't know how these programs act, right? What exactly is it doing? I don't really know that, so I can't, judge, when the user will actually see something, right? So response time isn't really going to be a fair thing for me to look at. So first come first serve is nice in terms of, I can use it on a system that's having jobs continuously created. The problem is, right, is that sometimes it's going to be slow. So sometimes I have this issue, what they call the conveyor effect. And basically what I'm saying is I have a bunch of processes that are running, right? And normally, right, the rule is I need to run them in the order I saw them in. What happens, right, if I get a large process followed by a bunch of small processes? For something like that, usually it would be better for me to run the small processes first because it'll reduce my waiting time, right? All those small things will complete, and then I get to the big thing, right? But if the big thing comes first come first serve says, well, you were first, I'm going to compute you first. And so I'll mark everything behind you wait, right? And so that's going to be an issue, right? And that's kind of a bottleneck that forms whenever you're doing first come first serve. So this is kind of our simplest algorithm, right? But it's not going to be, kind of the end all be all, right? We can certainly do better than this.